Hello, this is Alan Folmsby speaking from Maui. It's a little drizzly this morning here, 10 a.m., January 3rd, 2020. This is the future. You have arrived. I have a bunch of things I'm going to talk about in predicting the future. I'm pretty good at this, actually. I have a good track record. Part of the discussion will be about physics and the gravity volume theory. And then I'm just going to give you a little speech about the future now. Hello. So, here I am in the Maui Theoretical Physics Laboratories, and I have around me some things I'm going to be showing you, which I've already discussed last year. But looking to the future, we should be aware that nobody knows the future. Nobody knows if quarks will be discredited this year, or whether quarks would finally have some kind of a success. I keep hoping for the best. And when I was in college back in 1978, I studied quarks back then, and I wanted to believe in it. I thought in the future, sometime way in the year 2000, when people all have shaved heads and they have flying cars, then quarks will have some great proof that it's exactly the correct thing. And unfortunately, they have failed to come through. That's why I've stepped forward as a leadership member of the science community, and I'm making quarks obsolete, and I'm replacing it with the mirror in the center of the proton. So the protons are arranged into a cubic structure, as I've said many times before on these videos. And let me just emphasize the future key concept. The cube is a stacking of protons and neutrons in the center of iron, for example. And the cube has proton repulsion from primordial times, when the lattice was unterminated. These were not little nuclei terminated with a cube with each face terminated off. No, it was a cube that was not terminated back before expansion had gone on very long. The cube is a fossil from eternity. The pyramids on the faces of the cube were recent additions, after the expansion had ionized the nuclei from the neutraloid, a giant neutron star that used to contain all matter in the universe. Then electrons could guide the protons during fusion into lines of protons. So the point is that the nucleus has a cube at the center with protons repelling protons. But outside of the cube is not primordial. A recent addition are the pyramids of the terminated cubes, and this has lines of protons. Protons don't completely repel each other on the surface of the nucleus. Let me turn the camera around for a second so you can take a look at these things I'm talking about in terms of geometry. And as far as algebra goes, the conservation of energy is not good enough. That is a lumped functional model that in 1,000 years never would have told you the structure of the iron nucleus the way geometry will show it to you right now in 2020. So there's the picture of the iron nucleus silhouette. You might have seen this before in the videos from the previous decade, or from 2019 and 2018, I've been showing the iron videos to you. And what I'm saying is that here's the cube in the center here. Of course, the silhouette is only a square for the cube. The red would be protons and neutrons in a simple cubic lattice, and the black is protons and neutrons in a pyramid, which is a hexagonal close pack. And then the blue, say over here on cobalt, is the one additional proton for the incremental element. Iron is a foundation element, and cobalt is an incremental element. There are 18 foundation elements, and I could show you what it looks like here. For example, iron, and on the right are all the noble gases, and in the future it'll be recognized that these are all the correct shapes of all 118 elements. So now, instead of looking at the silhouette, we could look at the actual 3D model that I have put together as a sculpture. And in this way, you get to see the charge distribution. And in the future, chemistry will be greatly enhanced by understanding this charge distribution. Oh, here we have it now, the iron nucleus. See how different it looks from the silhouette? Oh, here's the silhouette view. There, that's just like what you saw there in silhouette. But now, with the charge distribution, all those baryons are identified as white protons and brown neutrons in this model. And it has two rings of protons in white, and they are coaxial rings. So they line up like that. And now other elements are unlike iron, and that's the important point. Not only does iron have two rings of protons creating ferromagnetism, but manganese, element 25, with one fewer proton, is not ferromagnetic. Let me show you that one. There's the manganese nucleus. It has a cube 2 at the center. So how very different it is from iron. It's extended and flattened out because it only has a cube 2 at the center. Iron has a 3-layer cube, so it's not flattened out. And these two rings you see in manganese, these are not coaxial. And one ring is ruined by that number 25 proton there, gets added on top of the earlier element 24. And how different that is from iron. Iron is simple. It's a foundation element. Manganese is very complicated. It's has 6 protons on top of the foundation of argon, which is visible in the periodic table. So let me zoom in here. Let's see, argon, there it is. And I'll bring argon into the screen here. There it is. So argon is a foundation element, and then in the future, people will agree that this is the correct description of nuclear structure, where quarks are not needed at all to describe magnetism or chemistry. And in fact, spherical protons and neutrons are the best way for the next century to show the shape of nuclear structure, I predict. Now, you see, argon doesn't have any blue protons on it here. That's up to the incremental elements like potassium. Oh, there it is, appearing on the left side here. There it is. On the left, you see it's like argon, but it's got that one blue there. And then calcium has two more blue protons, incremental elements. And so you get over on the right here, and you see there's the manganese has seven. 7 blue dots there on top of the foundation element argon. That's why it's so complicated. These spheres are fitted on there in the lowest pits. For example, in this picture, this sculpture here, I placed on top of the argon nucleus a lot of other ones in the lowest pits on argon. So it's a hydrodynamic simulation that I imagine happening. And I put it into the correct positions here. And these are predicted to be correct. And I already wrote a paper on this type of element, which is being submitted already, or it was submitted already. So I'm going to be announcing that new paper very soon. But before I get to that, I can't really announce things that are not published yet. But it's a major paper with a big breakthrough for the future of 2020. So, but I did already publish the gravity volume theory on my websites. And it says that gravity is from matter. And energy is not important in this gravity creation because all energy is relative to matter. So the idea is in physics that the space outside matter is relative to the space inside matter, inside the protons, neutrons, and potentially the atom. So I looked at maybe the volume of the atom has a volume that's affecting the volume of falling objects around the Earth. But that didn't work out very well. So I went to the volume of protons and neutrons, and that did work out well. And the space coming into matter for gravity is equal to the time growing out. And so that's a balance of nature. And in the future, this will be replacing a lot of other non-unified concepts. And in this, the volume of a proton, V, is very important. So a 1 second dropping of a rock is the experiment. And we drop it anywhere on Earth into one fallen shell. And that basically is the potential zone where 1 million people around the Earth could potentially drop a rock. And it would all fall at the same acceleration rate. And the volume of the height Z, fallen in 1 second, multiplied by the area of the Earth, is the volume of a fallen shell. It's like a onion layer around the Earth, just 4.9 meters high, and that's where the fallen shell is measured compared to the volume of protons and neutrons. So what I'm going to be getting at is showing up in about 24 seconds right after this message from our sponsor. Okay, I'm back in the spotlight here. I'm going to zoom in on the green outside here. And then I'm going to talk to you about the future concepts which standard science has been involved in, and future science. All right, I'm back in the couch area again. And as you can see, it's very green outside here on January 3rd, 2020. And the future is looking bright for Hawaii. Now, in the future, standard science has got to make some changes. For one thing, units of measure. What happened to you? The speed of light equals 1. Planck's constant equals 1, you've thrown out units of measure. You're saying the mass of a particle is a certain amount of energy. Why don't you just say the mass of an object is in kilograms? Are you so hypnotized by relativity and Einstein that you think we can now abandon units of measure? No. In the future, the mass equals area theory will be changing all that, as I explained in the earlier videos. Now, one thing that's important that I presented is the force primitive ideas in an earlier video, in which force is relative to the proton radius. And that's reflected in the formulas. Newton's universal gravitational constant has been factored to use the proton volume divided by a time constant. And in the gravity volume theory, I was able to find the universal gravity time constant of 5 nanoseconds, and that's how much time it takes for a proton to consume its own space from the surrounding volume. And space is treated as a liquid flowing into the proton, and an equal amount of time comes out of the proton when that happens. 5 nanoseconds comes out as a proton volume goes into a proton or neutron. So these things were very important, and that is related to the mirror in the center of the proton. And at the mirror is traction into the electromagnetic 4 dimensions. So it's an 8-dimensional thing where the electrical 3 space and the magnetic time direction are 4 dimensions that are in traction with gravity. So gravity is providing a potential power to atoms to replenish their orbitals at a very low rate. So when you go to cryogenic temperatures, you'll see in the future of 2020 that diamagnetism and gravity are both related to each other because they work right down to absolute zero. The reason you can't get to absolute zero is gravity is pushing back on you. Now, also along these ways is the chemical concepts of the chemical bond. This is a major part of the future. In the past, standard science said there's free electrons, there's free protons, and they're all not paired with each other unless we say they are in some special way. But it's just not true that electrons are free. They're always paired with one proton, according to new theories. But in the past, there was a gravitational field for a proton attracting another proton or something. And as you know, that goes in all directions the same amount. But also they assume that electrostatic attraction also follows that kind of a law, where the proton will repel another proton and attract another electron in the same way gravity will attract something in the same strength in every direction, isotropically. But so in the future, the pairing of a proton with one electron will be the new paradigm, and that shows how Lenz's law works, in which the motion of electrons making an eddy current is tracked by the motion of the proton currents in a nucleus or in a molecule. There are ring currents in iron flowing through the protons as if in a superconductor, but also in like benzene, there's a ring current of electrons going around that is being tracked by a ring current of proton current, and the lines connecting the electrons and protons in that vortex do not cross each other. That's the non-crossing law, which I've spoken of recently. All right, I have a list here of things I'm going to speak about now. Oh, there it is. So this is all part of the theory of enough. Now, in the theory of enough, I'm not covering everything, but I am covering the particulate theory of relativity, and that involves the relative radius of the proton compared to other radii. Hello, it's Alan Folmsby here in my front yard. This is where I discovered the shape of the iron nucleus. Ah, yes, had to get a drink there. Well, that was good. Water, H2O, hydrogen, two hydrogens at like an angle of 108 degrees or something. It's an oxygen, and then they're spread apart at an angle. They're not like in straight line with each other, all three atoms. No, the molecule is 108 degrees, say as an oxygen, and then two hydrogens. Okay, I have a little model of the oxygen nucleus. I'm going to show you a 108-degree angle in the nucleus for the positions of the protons. Check this out. Okay, I'm going to move this around here until we see oxygen. Oh, there it is. Let's zoom in on this oxygen here. So, as you see, there's a red cube there, and it only has 2 layers on it. So there's 8 protons and neutrons in there. And so the 2 protons in there are as far away from each other as they can get, which I will show you in a little model. Yeah, I'll get that model for you real soon here. Hello, it's Alan Folmsby here in my front yard. This is where I discovered the shape of the iron nucleus. Well, good. I'll find that model real soon, but for right now, let's just take a look at the silhouette, because basically this tells you everything I wanted to say. Okay, so I'm going to draw a little thing here of the angles, so that what I'm saying is the origin will be here, not in the center of the cube, but in the false cube up here. See, oxygen's different. It's got a stacking of two layers on top of a two-layer cube. So there's kind of a false cube up here on the top. And that gap in the center is the origin of 108 degrees. There will be a vertical member on that, and another one to this prominent proton off on the side here at a 108 degree angle. So I'm going to attempt to show you how that works out real soon. I'll tell you all about that in a later paper about why there's a 108 degree angle for that. All right, so I'm going to go back to giving a little speech over here. Oh, yes, let's see. I'm just going to be winding up for the last 5 minutes of 2020. This is the future. Yes, 2020. I remember the tokamak was going to be ready in 30 years. So that was 40 years ago. They're trying to build tokamaks for fusion energy. And they said, yeah, it'll probably take a long time, 30 years to get this fusion reactor going for electricity and everything. And then here we are 40 years later, and they're saying, it's going to take like another 30 years. We could probably accomplish a lot in 30 years using old science, using conservation of energy, pretending the nuclear structure is just a blur of chaotic gluons and quarks. Yeah, we're going to bet the future of electricity on that old, wrong theory. So I'm offering leadership. Dear scientists, I'm directing you to confirm the shape of the nucleus that I have already provided. And I hope in the future you will want to cooperate on this, because I'm going ahead with you or without you. Thank you very much. I'll be back on Monday.